Welcome, and this is a session on sandwich theorem, which is there as a in limit chapter. Now let's understand when do we use a sandwich theorem. Now sandwich theorem is used when we are not able to directly find the limit of a function, but we know of two functions, one above the given function and one below the given functions, which converge to the same value. Now just to make things more clear, let's understand this with the help of this example. Let's say this is limit n tending towards infinity, summation r is equal to 1 to n, r upon n square plus n plus r. Now clearly this is bothersome because we cannot factorize it. So what we can do, let's assume that the limit of the function is L. So clearly can we say that this limit L would be less than the limit of the function, a function say above it, summation r equals 1 to n r upon, this will be n square plus n. Now if the denominator is less, then the value is more. So can we say plus 1? It would always be more than this, it would always be less than this, and the limit, which means this function, right, this function value would be more than this limit n tending towards infinity. This is summation r going from 1 to n, this is r upon n square plus n, right? So if we increase the denominator, the value decreases. So the limit that we are required to find actually lies between this function, right, and this function. And clearly what we see over here, we also know that summation r is nothing but n into n plus 1 upon 2. So clearly if we put those values, the limit L, this would be the upper hand, the upper limit, the upper function would be converging to this summation r is nothing but, if I put the value n into n plus 1 upon 2, and in bracket we have n square plus n plus 1, right? Now if I can take n square common from here, then this limit would be less than what? This limit n tending towards infinity, if I take n square outside, the value is, and cancel it from both the terms, 1 plus 1 by n into 2 times, this is 1 plus 1 by n plus 1 by n square, which means if n is tending towards infinity, this term and this term goes to 0, which means the limit is 1 by 2 on the upper hand side. Below side, by using a similar logic, we can see that limit of the function, see summation r again becomes n into n plus 1 by 2, and clearly what do we see over here, it is n square plus 2n, right? So basically if we take again the n square outside from here, this will become 1 plus 1 by n upon 2 times, this is 1 plus 2 by n. By same logic we can say that if n is tending towards 0, this and this will, sorry, towards infinity, 1 by n and 2 by n will go towards 0, which means again the lower hand side, this also converges to the value 1 by 2. Therefore, since the function is between the two functions and both the functions converges to 1 by 2, therefore we can say that the functional limit or the limiting value of this expression is 1 by 2. Thanks for watching this video.